Thanks again. I always seem to forget that part. All right, so we're recording now. We're going over the Boggle challenge. So again, just to find words, you can go in any of the 8 directions. So if I start at this I get in, it, is. What else can I make? I can make R-A-G, so rag. You can change directions. So I could go from the R to the A to the N. So I can make ran, I can make rant, go in here. So that's kind of a challenge of Boggle when you're playing it. It's a fun little word game. All right, so I'm going to start with forking this to my personal GitHub. All right, so I forked it over. Copy that URL, and looks like I'm on the wrong tab. Oh, that's not good. I think I screwed up. Oh, there it is. All right. Let's say I upgraded my Xcode finally, and hopefully I'm not going to run into any errors there. All right, so I have code Oscar challenges. I want to do a git clone of that path. All right, simple enough. And then we could open up that directory. So we have Boggle and code. Okay, open up my wrong window. Let me toss that over here. All right, here we go. We have Boggle board. We have a README. So let's kind of make sure we understand what we're doing. All right, so we talked about the game. Step 1, basic Boggle board. So our goal here, it looks like, is to implement this Boggle board class. This Boggle board class should be able to output something that looks like this, where we have a simulation of what our Boggle board would look like. So these are just random letters that are kind of generated from dice eventually. So part 2 will be implementing dice here. But part 1 is just going to be implementing something that outputs a Boggle board representation. Okay, so looks like our first goal is to initialize our Boggle board and just have it be empty. So have underscores, it looks like. And then when you hit the shake method, which is subbed out for us, I guess we should add some passes here. So this runs. We want to be able to put out random letters. When I hit shake again, it should randomly generate the board again. Okay, seems doable to me. So let's get to our Boggle board. I'm actually going to create a runner file just to kind of separate logic out. But Boggle board will have our core functionality here. So let me tab this appropriately. All right, Boggle board. Any parameters we need to take in? I'm trying to think. Right now, I can't think of anything, but I do want to create some class level parameters. So let's just say alphabet, be 1. All right, so I'm going to create this. It's going to be temporary. So our first goal is, again, just to be able to, whoops. Our first goal is to be able to, sorry, I'm having some Zoom issues here. Okay, to just output any random letters, right? We don't have any particular input that we're getting. Eventually, we're going to be using these dice, which represent the actual physical dice that exist in the game. Then we have a challenge with QU. So, all right, 3 parts to this. So first part, my goal is to get something that looks like this. All right, so I have my alphabet. My init method right now, I don't think I need anything that I need to pass in there. So I could just have a kind of an empty looking init method. I could even get rid of this if I don't need it. It's totally fine not to have an init method. If you don't have one, a default one kind of just gets created behind the scenes. But my shake method needs to do something. I need to print out, let's see. So I could do something like, what do I want to do here? So I need, looks like it's a 4x4 grid. So that's something I could hard code, or I could kind of have that as some variable. So I'm going to do this here. Do length equals 4. So this is one side. So in case, again, this is the idea of future proofing in terms of, let's say, in the future we have a Boggle board that can be 5 by 5. Making it sort of flexible here, where I could just change one value, is better design, I would argue, than kind of just hard coding in and having 16 values, kind of hard coded in various places. So me relying on this length of the Boggle board class, so that I could, again, make that flexible should need to be in the future. Okay, so I need to print out something. I think I need my init method back now that I'm thinking about it. So let's recreate that. Because I want to create some instance attributes. And init method's a great place to do it because they're guaranteed to exist at that point. As Tom mentioned yesterday, you can create new instance methods in any other method or even outside of instance methods. Like I create something, here. That's totally fine, but the only problem here is this is not guaranteed to exist when this class gets created because the shake method needs to be called in order for something to exist. The init method, as we talked about, automatically gets called when you create an instance of your class. So again, this is a sensible place to put things that you want guaranteed to be around. So in this case, I'm going to create a board attribute, and that's going to be a list. So it's going to contain a list of, I guess, letters eventually. But to start, it's going to be underscores, and I'm going to use list comprehension. That's something that we went over last week, just an advanced way or a different way to populate a list. So I'm going to do that for range. Again, if you guys have any questions about anything I'm typing, please do ask. Okay, so this is a list comprehension. There might be some new things that we introduced there. So this underscore that I added here, I'm not sure if we talked about this or if you've seen it. This is a Python convention saying this is a variable that I'm not using for anything. So instead of putting an underscore here, I could totally put an X or put, something, anything I want to name. This is just a variable that I'm creating. In this case, I'm not actually using this value from this for loop, right? Because I'm going over some range. In this case, it's length squared. So length squared is going to be 16 in this case when length is 4. So I'm going to do, I'm going to conduct this loop 16 times, but I don't really care the value, the iteration value, right? I don't care if it's 1 or 7 or 12, whatever. I just want 16 underscores here. So this value for me right now is unnecessary. So I'm just going to put underscore. This underscore just means it's some variable that we're not using. And so Python won't really care about this variable. All right, so it's going to populate 16 underscores into my board. And then shake should do something, but I'm actually going to create a new instance method. Again, it's always good to separate functionality. So I'm going to create a define print method. And the print method will be responsible for simply printing out my board. All right, so print, I'm actually going to make this a for loop. So for x in self.board. So we'll print 1 by 1. And so key thing here, we need to add some new lines. Notice this is not on a single line. And so we're going to add a new line break every 4 steps or every length that we go. So in that case, we could do something like we enumerate, we get our index value that we could leverage. So we're going to print x, and then we could do something like if I is a multiple of boggleboard.length. All right, so we're checking if there's no remainder. How do we want to do this? So if x equals 0, 1, 2, and 3, that's going to be the first row. So after 3, we need to add a new line. So this won't quite work because we need I to be 3 when we want a new line. So we could do what we want to do here.
Hey, Walker, what's the difference between referencing length by the class name and using self?
Oh, great question. I'm glad you brought that up. So I actually probably should use self here. That's a good point. The difference is when we talk about overwriting. So technically, I could create a self.length here. So yeah, let's make this a little more complex to see why that might matter. So if let's say I had a self.length here. In this case, it's always going to prefer this .length over this one. So actually, I like that question or suggestion. Always good to use self unless you explicitly know that you don't want to overwrite it. So the reason why this might be something you care about is, let's say we had an input of custom length, right? And that could be none by default. So if we had something like this, where none is a default, so if our user just didn't specify a custom length, we should fall back to our defined length of 4. But if they did provide something, so we could check if custom length is not none, then we could do self.length equals custom length. So I think, yeah, this would be a good example of why, yeah, it might be better to use self if you want to allow customization, so that if the user provides something, we'll have an instance attribute for length that we're going to use. If if the user did not provide a custom length, then we'll fall back to the class attribute. So again, I think it's definitely better to use self in this case, because that allows us to use an instance attribute if we want it. All right, so I'm actually going to keep this in here just in case we want to customize it. It'd be kind of cool to see how we can do that. All right, so I'm going to change this to I+1, take the modulo of it and see if that is 0. If it is, then we want to add a new line in here. All right, so I'm writing a lot of code. I probably want to test it though. So, all right, I have a shake method that's doing nothing. So let me get rid of that. My goal right now is focus on this part. When a new Boggle board is initialized, the output should look like this. So that's my goal right now. All right, so I have my init. I have my print. I need to hook these two up. So it looks like whenever we initialize something, we should print our board. So I probably want to name this something different. Let's name it print board, just not to confuse it with print. So I'll do self.print board. All right, so one thing I want to highlight, notice I'm not passing anything in the print board. The reason is because my self has this board attribute already on it. So I don't need to pass, I don't need to pass this board here. It's not going to break, right? I could definitely take in a board here and just use the board like such. But again, if we already have access to self, it kind of makes it unnecessary to pass around extra parameters when self already has that value on it, right? Hopefully that's clear. All right, so I don't need to pass any parameters. Self automatically will get passed, and then I could leverage self in this instance method. All right, so what do I want to do here? Let's add some comments. I always have to have comments. So make sure we add a new line. Not sure these comments are helpful, but good to have them in there. All right, so initialize board, and we print out board. Okay, let's give this a run. So I'm gonna go to my runner file. I want to include Boggle board, so I'm gonna do from my Boggle board file. Again, we don't need to put the .py. I want to import a Boggle board class. VS Code identifies it. All right, so I want to create a Boggle board. So name it BB, Boggle board. In this case, I'm not going to pass it anything right now. Again, we do have the option. So since we have a parameter with a default value, this is an optional parameter. If I don't specify it, it's going to default to none. If I do specify something, then we'll use it here. So runner, Boggle board, and I think that's all we need, because our Boggle board init method calls print board. So that should ideally, if we did everything correctly, give us something like this. But that's why we're testing. We shouldn't assume. So I'm going to save this, bring up my terminal with control tilde, and going to run my runner file. Python runner.py. Okay, I definitely screwed up here. So notice I get my underscores. Looks like there's 16 of them. but I'm adding a new line each time. That's not good. Okay, so I believe the issue is this print. This print's going to be adding a new line each time. So that's not quite what I want to do here. How do I get around that? So I'm actually not sure. Let's kind of read about it. Print.
I think you could have like a string that catches each of the underscores, and then each time you hit a new line, after you print the string, you just put string back to blank.
You mean so create a string and then output that string? Yeah, I think that's a good suggestion. I'm just actually curious if you could print without new line. Just curious about it. Always good to learn new skills. But yeah, I like Jack's suggestion. That's probably the way I'll go about it. So how do you print without new line? Oh, yeah. So apparently there's an extra parameter you can pass the print. I actually never knew this because I've always kind of worked around it. But yeah, it looks like there's an optional parameter. So we talked about, again, optional parameters. It looks like there's an end value, and I assume the default value for end is new line. But if you want to control it, you can specify it. So I'm actually going to try that, see if that solves our problem. So print, and now I'm going to say each of these print statements should end with an empty character instead of a new line. All right, so if I save this, let's clear my terminal, give that a run one more time. All right, there we go. We get something that looks like what I was going for. I'm not sure are there extra gaps here? Let me find out. Oh, that didn't help. Sorry, I'm not sure if there's extra gaps here or if that's what I should expect. What did I go? Oh. Sorry. All right, so ran my file. I think this is, yeah, let's see. Highlight this. No, there is an extra new line in there, I believe. Yeah, so there's a new row
One
here.
for the print and one for the new line that you're printing.
Gotcha. Good catch, Don. All right, so yeah, I'm printing a new line, but then it's automatically adding a new line. This is kind of a weird situation. Can I just print empty character? Will that take care of it for me then? All right, that works. Yeah, so again, the print is always adding a new line by default because the end value, the default, if we looked into it, can I actually dive into it? Print. All right, these are always hard to read, but there's an end value. Oh, don't know how to decipher these dots here. All right, let's forget that. Okay, so print new line. I actually don't like the way we're kind of assuming here, so let's do end equals that. Add a new line. Guess we don't need that comment. Okay, so we got, I think our objective looks like it's been met for, I guess, part 1 of 1, which was when you initialize a Boggle board, you should output empty or underscores as your board representation. But then we have our shake method. So our shake method should output actual letters, right? So we implemented print board, so that looks good. I'm gonna actually move that up so I can write my shake method. So print board. Again, we didn't require or ask for a new method, but that's just, again, breaking our code into separate, smaller parts. So print board, only job of print board is to print out our board. It's not doing anything else. Shake is going to do something a bit different. So we have our board initialized. We need to fill those with actual letters. So let's do a for loop. Let's do enumerate again. In this case, I don't care about this variable. Again, that's the underscore that I talked about before. And I'm going to do enumerate, and it's going to be self.board.
I think you're going to have the in keyword.
Thank you.
Ankur, if you've got time for a quick question, I know that they're separate function or separate methods, excuse me, but would it be kind of best practice to still kind of change the name of I in this new shake self, just so it doesn't, I guess, just like good coding practice, you know, just to make it like readable for.
Are you talking about against this I or just like naming it a little better?
Yeah, oh no, I mean just like maybe like, you know, using J or K or something just to. differentiate, you know?
Gotcha. Yeah. So I would say, again, in terms of my opinion, I would say I like being consistent with like index. I always try to use I when I can. Yeah, they are different methods. So again, these are all local variables. So it should be clear enough that, you know, this method has these two values. So these values are not going to carry over to another method. So again, it might be personal preference if you want to, you know, try differentiating them just because, you know, it makes it easier to understand like, hey, this I is not associated with it. Go for it. Like that's, I guess I'd leave that up to the developer preference. In my case, I just like defaulting to I for index. I think it's common convention that most developers probably will understand whenever they see an I, they'll interpret that as index. And then yeah, J is like the secondary, I guess, backup character for index if I cannot be used. Yep, great questions. So we have I. We're going through this board again. This underscore, I don't care about the actual value because I'm actually writing my own value. So I'm going to do self.board I, and then I want to write some character into it. So I have this alphabet that I created. This is a class level attribute. Again, hopefully everyone at this point understands class level attribute versus instance attribute. The reason I made this a class level attribute is because the alphabet is the same for every Boggle board. I guess, assuming we're creating an English Boggle board, the alphabet's going to be the same. So if you wanted to create like a international Boggle board that, you know, handles different languages, well, or different, I guess, alphabets. So there's non-Latin alphabets out there. We might want to reconsider this or maybe make a different type of class. But for now, I'm just going to assume that we're sticking with English or the Latin alphabet. So self.board, and I want to grab a random value from here. How do I grab random values? So I'm going to hit the Google. So I think there's a random module, random Python. Random module, W3 schools, great. All right, random module has a set of methods. Let's look for an example, no examples provided.
Choice is pretty useful.
Yep, yeah, I think I've used choice before also. Yep, choice, I think that's something we might want to use. Oops, clicked on something. So return a random element from a non-empty sequence. You sequence empty, radius index error. All right, yep, I think choice seems like it'd be a great choice. So I think I need to import random.
Can your choices be a string?
Yeah, so it says sequence. So strings and arrays are similar in that you can iterate through them. So I think you could just use a string. I might be mistaken, but again, always worth trying. So if I do random.choice and pass it my string, so it's self.alphabet. Again, we can use the self here because in case, let's say we want to pass a custom alphabet, like let's say we want to exclude Z's because these can be hard to make words with. We could, you know, theoretically have another parameter where we say custom alphabet. All right, so self.alphabet, random choice. Okay, is that all we need? Not sure. Self.printBoard. All right, so we update all of our board indices or values at each index, and then we call printBoard. So I think that's all of our shake might need. I don't know if we need anything else, but I'm just going to give it a try. And if it doesn't work, we could obviously fix it up. So I'm going to call pb shake, which will invoke this method. Again, the self parameter, I don't need to pass in, right? I'm not passing in anything to shake, but this is a parameter that's going to be kind of passed in through the class structure. All right, so iterate through our board and assign a random alphabet character. Okay, so that does that, and then we print our board. Probably don't need this, but whatever. All right, so let's give this a run, and let's see what happens. So I'm going to do Python runner. Okay, so yep, looks like we got a board. We got two X's. That's kind of tough for actual game. Probably hard to make words. We got a Q also. X and Q and J. Yeah, these picks pretty unfavorable letters. Maybe I want to update my alphabet so I don't have X's and J's. But all right, cool. That seemed like to print out what we wanted. A little hard to read here. So we print out two boards, the empty board and the new one. So maybe I want to add like a new line every time I print out a board. I'm going to just do that here. Sure, let's add, I don't know. Ooh, what happened there? All right. I'll just print out one new line. Okay, let's see how that looks. That is not what I wanted. That's in my for loop. Okay, there we go. So extra space just to make this easy to read. So we have empty board and then our new board. This one looks a little friendlier, fewer X's and J's. There's a Z, but can we make any word from here? Anyone spot a word, a good word?
ARF.
ARF? Not sure if that's
Start that out with
You got a
one.
RAM on a reverse diagonal in
Yep.
the like bottom right to the left.
RAM. Is there a four-letter
No,
word?
MRAD.
Anyone have a four-letter word?
MRAD.
What was that?
MRAD, like the measurement on reticles.
Or milliradians or
Pram is in there.
Pram. Is Pram a word? Again, I'm terrible with word games, so
Mad's in there.
mad.
And a V.
Okay. Yeah. So I'm sure there's complicated words we could get out of here. Again, I'm terrible with word games like Scrabble, whatever. I don't do too well. I'm a numbers person, not a word person. All right. But yeah, that's our Boggle board. Cool. Looks like our shake method seems to be working. Again, one of the requirements for shake was, sorry, where we go here? When you call shake again, it should generate a new board. So let's see if that actually happens. BB shake. Let's actually put this in a while loop. So I'm going to do let. I don't need to do let. It's JavaScript. Let's do this. Let's do this 4 times. So while I is greater than 0, let's shake this up. Okay, and we need to update our I. So I is going to be decrementing in this case. All right, so I'm going to do this 4 times. Let's give that a run. Okay, so first time, initialize to empty, or basically underscores, then we call shake. We get a board, we call shake 4 times, so we get 4 boards. All right, looks like I think shake's working. Might want to test this out more, but I don't think there's too much to test. Like I'm calling shake, it prints out the board. Don't see me getting any errors or any weird cases. So yeah, I think this should take care of part 1. Maybe you want to just double check the requirements, but shake.
So I have a question about unit test here. If we were going to set up a test for this, obviously the only way we could do it is if we were able to seed the random and make it come out the same every time.
Right.
But actually, that's not even going to work.
That's right. Yeah. So we could. Yeah. So when dealing with like random cases, it is a little hard to test. As Don said, we could try to seed our random generator. Let's actually see if we quickly do that, because we are going to come out with cases where we might have random output. So let's create a new unit test. Let's call it Boggle board spec.py. Yeah, let's quickly create some unit tests. Great idea. So I need to import unit test. Let's go through this a little quickly. Hopefully we're familiar with all the steps. I want to do the if name equal main. This simply we call unit test main to initialize it. And then we need to create our test case suite. So this will be a class. Let's call this Boggle board test cases. All right, let's create a test case here. So if I do test, how do you want to do this?
Do you want to test the size of the board first to see if you have the right size?
Yeah, that's a good idea. So in this case, I'm going to have my print board also return my board, just to make this a little easier. So print board will actually output it and then return it, so we could actually check out what the board looks like at that point. So test board size. So I guess in this case, we should expect 16. So let's take self. All right, let's create a Boggle board. And then self asserts equals. So bb.printBoard, or I guess we could check board. in a simpler case, a board should just be 16, right? Because we initialize it with 16, or not necessarily 16, but using length. So length of board should be 16. Okay, that's a simple initial board size. Add another test case. All right, so the main thing I wanted to try was, can we test a random output? So I think Don had a good idea. He said we could try seeding a random number generator. So let's look into seeding a random seed. I'm actually going to hit Google, make it a little easier. So how to seed All right, so seed takes in seed value of A. Okay, so let's use something like import a random here. Not sure if I'm doing this correctly. So if we do random.seed some value, create a Boggle board, and then we do Boggle board print board. Let's see what that spits out. Sorry, give me a moment here. So custom length, let's just make that 4. Let's say seed equals 7. Will that work here? No, because all right, so I'm adding a new parameter. This is going to be if I want to seed my random generator, I should be allowed to. So if I do if random seed is not none, I think I don't actually need to check is not none. I think if this is a non-none value, I'll evaluate the true, but just be explicit here. I will do that. So random seed equals random seed. And then I guess I don't even do that. Let's do random. All right, let's give this a try. I'm not sure if I'm doing this correctly, but we'll find out. So right now, I don't want to run this test case. I want to run my runner. All right, so my goal here is to see if I could guarantee my random output each time. So if I do Python runner, I get BCOE on the first line. If I run this again, will this actually do that? Nope, that did not, because I did not pass in a value here. So Boggle board will take in 4 and 7. Get KEMU. If I clear this, I get KEMU. All right. So what's going on here? I kind of, again, been adding stuff without talking too much about it. The random module, the way randomness is kind of implemented on computers is that it takes a seed value. If you don't pass it a seed value, it's going to use the current system time. So the current system time is like a large number of seconds since the epoch or whatever default starting time. So that's going to be the random seed based on the time you execute the code. The time value is going to be unique each time. If you specify a default, like a static value, so in this case, I'm passing 7. Again, 7 was just a number I picked out of the top of my head. If you make this any constant value, your random orderings are going to be predefined. So if I make this 7 and ran my board 4 times, I'm going to get the same 4 boards each time because it's going to use the same random sequence each time. So if I run this, notice I get KEMU as the first board. Again, the whole board here. Second board is NCHC. If I run this again, the sequence is the same. The random sequence is just auto-generated, and it uses that to be quasi-random. So again, computers aren't actually fully random. There's some logic behind it, but it's pseudo-random where it's good enough for our purposes. So we're getting a set output here. Oops. So now that we are getting a set output, we can compare that against what we expect from our output for our test cases. Again, this isn't, I don't know, I'm not quite sure what to say on this in terms of we're using our output and then going to use that output to test against. That's not necessarily the best test case because, again, those values should be independent. We should have the correct value kind of generated separately and then see what our program's outputting. In this case, since we're dealing with random values, I'm just going to go with this. So now if we add more code and this breaks, then we should be able to identify where it's breaking or that something broke at least. So if I go to my spec file, let's do test random board self, and then again, we can just do basically what we did on our file. So if I pass in this, I'm actually going to swap custom length. Actually, I don't need to do that. So if I go back to my spec file.
Ankur, I kind of got a question, and it may be totally wrong.
No, please ask.
So is there a way to maybe output like that first roll to maybe like a CSV and lock it so it doesn't like change as you update it, like using dict reader or anything like that?
Sorry, this value?
Yeah, so like you can actually use that as like a reference like for your test case.
Yeah, yeah, I could probably output this and test it that way. That's not a bad idea. But in this case, I'm just going to hard code it in my test case just to kind of save time. But yeah, again, hard coding value is not always the best. But since we're dealing with random outputs, to me, this was a good way to kind of just initially test that we're getting some output that's randomized. So I do this. What else do I need? So this is going to be an array, or a list. That should work. I'm going to do assert equal. All right, so print board should be called here, or we call shake. Let's call shake instead. All right, so shake's going to return our board now instead of print board. So shake will call print board and return the updated board. And then here I'm going to call shake, and shake should equal our expected output if we did everything correctly. All right, so again, the whole point of this was to see how we could technically test like a random output if we control the seed we're passing in here. So let's see if this gives us what we want. Okay. I don't want to run the runner, I want to run the spec file. So Boggle board spec. All right, ran 2 tests. We failed one of them. What we failed? Got an unspected keyword, custom seed. What did I name that? Named it random seed, not custom seed. All right, ran that again. Did not get that. 16. Oh, no. Don't want the length here. We want the actual board. My bad. Let's try this again. 3rd time's the charm, hopefully. Okay, we ran 2 tests. We passed them. So this dot means we passed them. Again, we're kind of combining the output here. So not easiest to see, but we passed 1 test case, and then we called shake, which printed out that board. So it looks like we're passing that. Again, just one way to kind of test pseudo-randomness if you control the seed here. So I'd say that's one way you can write unit tests for a random occurrence if you kind of understand what the output should be, and then make sure. So now from this point on, as we add more code, if this breaks, then we know that we actually somehow broke our logic. Okay, so I'm just gonna keep those 2 test cases. Obviously, we probably add more, like check the format if we wanted to check the format. Maybe we could add like print board can return its output, but yeah, for now I'm not going to add any more test cases. Go back to our Boggle board. All right, so with that slight detour, I think we completed part 1. So part 1 was having outputs here, having a shake method that seems to work. So I'm going to incrementally commit basic Boggle board. Let's do that. So do a git add git commit. Okay, so that's saved. We have a save point in case we need to go back to it, but let's go to part 2 and see what that's asking for. All right, so smart Boggle board. So in the actual game, you're given dice. The dice have 6 faces, and each face has a letter of the alphabet on it. So we're given some input here. So these are dice values that that are, I believe, from the actual game. So so there's a QU case. We're gonna worry about that later, which is part 3. Let's deal with this part. So I'm gonna just grab this, and then how do we want to do this? Runner file. Okay, so we need to initialize our dice. I'm going to do that in my runner file here. And we're given this list of characters. So there's 2 ways we go about this. One way is we could simply pass in these strings and have our Boggle board kind of take a value. Actually, going to look up something. So Visual Studio Code multi-cursor. Some of you guys might know this trick already. I've done it before. I just always forget the combination. It's Control-Alt-Down. That's selection. So I'll try it. Control. Anyone know how to do the multi-cursor trick?
I believe it's Shift Command.
Shift Command. Shift Command. Shift Command, is there any other key with it? Let's see. Mac Shift Command L. Let's give that a try. All right, there's a way to create these multiple cursors. All right, I'm not going to waste time on it, but it ideally should have saved me time here.
I tried to find the cool way of doing this and failed and just ended
think
up.
it's,
You can't hit shift parens or shift quotes. It'll at least do it for you a little faster.
Shift friends.
Quote with the item selected.
Oh, okay.
It's Option Command up or Option Command down.
Gotcha. That sounds right. Definitely done it before. Option Command. Is that a Windows or Mac?
Mac. So like Option Command, like hold Option Command and then tap up or down on the cursor or on the arrow keys.
Okay, I can do the up, but I can't do the down for some reason. All right, so let's try that. So do this. All right, so multiple cursors, cool. And I'll move over. Yeah, for some reason my down doesn't work, but my up does. All right, cool. So that's what I want to do.
That's wild.
Yeah, again, Visual Studio has some pretty nifty.
Quick question.
Yep.
Are you just building off the original Boggle file and not going into, or at least pulling the Boggle-2 one?
Say that again, Stephen.
We're just continuing on just the regular Boggle
Yep.
one. Is that correct? Not opening up Boggle 2. Is that correct?
Correct. Yeah, we're still on the first Boggle challenge, not the extended challenge. So we're just doing the smart Boggle board step 2.
Oh, okay, gotcha.
Yep. Okay, so we're employing these dice or this representation of dice. So let's make this a list. All right, so dice list. It's going to be this array. Let's get more space here. All right, so these are our dice. We want to use this in our game. So again, there's 2 ways to go about this. Sorry for that detour. One way is we just use these, strings and kind of grab a random character out of here. But I would think the better way to do it, as I mentioned yesterday at Sandown, is to actually create dice objects. So this is something we didn't ask for, but that's something I would hope that you guys were kind of thinking of, like, hey, dice are actual objects in the real world. it makes sense to kind of create those separately from the Boggle board, right? So they're two different elements that kind of are working together, rather than the Boggle board kind of just like owning the dice and like actually simulating the dice itself. So before we do that, I think it'd be a good time to take a break. Don't want to go too long here. So I have 9:24 here. Let's take a 6-minute break, so kind of a shorter break, and we'll kind of complete this challenge that we're going through. All right, so see you guys in a bit.
Ankur, quick question. Could you just scroll down real quick to the bottom of your runner file?
Sure.
Okay. Yeah, no worries. Thank you.
Is this font readable here?
No, it's pretty good.
Before we proceed, I definitely want to make sure we're not rushing through anything. Were there any questions from part one, or I guess part 1 of 1 for the Boggle challenge? Any questions about what we implemented on a Boggle board here? Any questions kind of left unanswered?
Small minor question. The enumerate keyword is essentially a nested for loop. Is that correct?
Nested for loop. I want to say no, it's not a nested for loop. But let's actually check the details of enumerate.
It returns both the index and the value over a range.
Yeah, so yeah, it's not, I wouldn't say it's a nested for loop. Yeah, so enumerate is taking in board, we're taking in a sequence, and then let's see if we could get to the definition. Always try to do this. No, as always, not going to get anything useful here. But yeah, so basically, instead of just giving you back the value, so it's gonna enumerate just kind of gives you an added index back. So it's not, I don't think it's looping over board the first time and then going through our board through our for loop here. I think each step it's gonna create, it's gonna extract the value and then give us an index. So it's I don't think it's n squared complexity, or again, nested for loop. So when we don't have enumerate, we just get the value back, right? So we do x in board. This is gonna, each step of the way, we're just gonna get our value back at that index. But if we actually want that index, there's multiple ways we could do it. We also keep track of the index ourselves. So if we want to do something like, I equals 0, and then at the end of our loop, we could do I plus equals 0. This is another way you can implement that index value. You can just count it yourself. Enumerate is just kind of a, a nicer or built-in way to kind of get that functionality without you having to create your own I value here. Otherwise, this would work exactly the same as we were doing before. So yeah, I wouldn't say that's a nested, we're not implementing a nested for loop here. All right, but yep, always worth asking questions if anything's unclear. Anything else from what we coded up so far? So I guess we didn't test out this custom length, but again, since we are using self.length in every place that I saw, so self.length, we should be able to customize it. So that's something maybe we quickly test. So if I pass in a custom length value, so let's do that in our runner file. Dice list can stay, Boggle boards, let's do custom length, or maybe I should probably call this size instead of length, but let's make it a 6x6, and seed value can still be 7. And I'll get rid of that. Okay, let's try 6, see if this works. Python runner. All right, there we go. So it's a 6x6. So it seems like we create as big or small the Boggle board as we want. So that's kind of cool. I did have a thought over break, and our spec's going to break. This random test is going to break when we change it to dice. So yeah, again, testing random items, not always easy, but let's kind of just go through what part 2, which is adding these dice values in here. So what I'm going to do here is create a new file. I'm going to call this Boggle dice.py. Again, always good to separate out new classes or new objects you're creating into separate files. So here, be a new class called Boggle dice. Here to nothing. We'll define an init method. And this init method will take in a string, dice string. So that's going to be those 6 characters that we pass in. and then we'll store that internally. So self dot values equals dice string. And then let's see, we have that. All right, so I have my dice list. I want to create a bunch of dice from it. So let's say dice values list and dice list. So I'm going to use list comprehension again. So here I want to create dice. I probably need to import this. So we'll do from Boggle dice import Boggle dice. I'm going to do Boggle dice for string in dice values list. Okay, so I'm just iterating over this, grabbing the string. So that's my S value, and then Boggle dice will take in that S as a parameter. So it's going to create a Boggle dice for each entry that I have in here. I believe there's 16 in here because we had 16 cells. Yep, 8, 12, 16. Yep, so this should create 16 dice for us that we can use with our Boggle board. All right, so Boggle board can take in dice list. So let's make that the first parameter. And go back to my Boggle board. Sorry. Okay, so what are we doing here? So we have Boggle dice, Boggle board here. Should take in some dice. So I'll do dice list as a parameter, and that will be stored.
Should we expect that method to go ahead and shake the things and just return a string of the 16 results?
Say that again, Don?
Should we have that method go ahead and shake the dice and just return a string of 16 results?
Which method?
The dice.
So here, Init.
No, when you said that it's going to return the dies, but we don't really need the individual dies, right? If we just have a method that uses that list of dice and shakes them and returns a string of 16 results.
You mean this? So you're saying we could just use this this list and grab random values from each of the indices?
Well, your dice method's going to read that list, and then rather than return individual dies to us, it might as well go ahead and shake it and just return the 16 results we need.
Yep. So yeah, so that's something I was talking about earlier. So we could, again, just use these strings and not really create dice objects. The reason for my design, I'm creating dice objects is so, again, I have those individual pieces so that if my dice need to do anything more, I can implement that inside my dice class. So I'm going to add more to my dice class. But you're right, we don't have to create dice objects. So this is going back to designing your algorithm or your application. So again, you can totally get the correct results without having that. But again, from an OOP standpoint, you want to create individual objects to represent, I guess, real world objects. So we'll see. Hopefully we kind of see the value of Boggle dice. Again, you don't need to. So you're right. This is totally optional. An optional, I guess, step that I'm taking by creating this Boggle dice object. So again, it might be, again, easier to avoid creating this Boggle dice object, but again, the question is, what's the better design? And that's, again, can be subjective at times. So I'm not saying like this is 100% the way to do it, but in my head, it kind of makes sense to create a Boggle dice object or a class for it. So we create a dice list from our values list. And then we have these dice that I'm passing to my Boggle board, so my Boggle board can use them. So Boggle board takes in the dice list now, and we store that as an instance attribute because each Boggle board, I guess each Boggle board in this case would have the same dice, right? Because this is a fixed list for each Boggle board. So we can maybe make that a class level attribute. I'm not sure. So I'm going to make that dice list equals. So I guess I could specify that. dice list is empty. Yeah, I'm not sure if, yeah, maybe class level attributes at this point make sense. Theoretically, maybe we want to have the ability to use any sort of dice, but yeah, I'll specify that here. So Boggle board dice list is dice list. All right, so maybe just get rid of the intermediary here. All right, so we're going to use the same set of dice for each Boggle board. So this is a design decision I'm making. If I rethink it and say, hey, maybe each game should have unique dice, then I might want to change my design here. So we have Boggle board dice list, and then that's a class level attribute that we're setting here. And then what else do we want to do here? So instead of using our alphabet, which is our using down here, it's a random choice here. So this is where we would want to maybe check. So if self dot let's see here. Sorry, I'm having some thoughts here. So one thing we want to do is maybe do an insert and check that self.dicelist equal length. All right, so I'm adding a check here to make sure that our dice list, if we have one, should be equal to the length of our board, because otherwise we're going to run some trouble. You know what? I'm actually going to undo what I'm doing here. I'm going to make a class or instance attribute instead of a class level attribute, just because since we can technically customize the length, it doesn't make sense to have a fixed dice list. All right, so going back to an instance attribute, make this dice list. Sorry for that detour. But yeah, so this is not going to be a class level attribute. I think it makes sense to me as being an instance attribute. So each Boggle board will have its own dice list. In this case, it's going to be fixed, but we could totally change that if we need to. Custom length. All right. So whatever dice list we pass in still should adhere to that rule that we were talking about. So the length of our dice list that's passed in should equal self.length squared. And this should be done after this point right here. Always get to add a comment. So dice list size must match size. All right, so this assert, again, it's just going to check for us. If that's not true, it'll throw up some error. Length of dice list equals that. Okay, so I think we're on the right track here. We have our dice list from our runner file. We create Boggle dice, pass it to our Boggle board, and then our Boggle board should be using that down here. So instead of doing random choice self.alphabet, we should do it for our Boggle board. So since we guaranteed here, or at least doing this check, that the length of the dice mirrors the length or the size of our board, then we should be able to guarantee that we can iterate over both. So this I value can iterate over the board and the dice list, and we use the index for both. So I'll do self.dicelist.I. Now here's where, again, another design decision that I'm going to come upon. So right now, our Boggle board is the one getting a random value from our dice. So we have a dice list. Each dice list index or value at the index is a Boggle dice object, and then we're getting a random choice from it. This is where, again, I'm kind of thinking in the real world, like dice, the property to kind of randomly get a value or roll a dice should be something that the dice is managing, not the board. So again, this is kind of separating or I guess organizing functionality. So when we talk about that black box where we hand you like a functional component, that box should be able to do everything that it needs to do for its object. So I'm going to suggest that we create a method here called roll, and all roll will do is return a random value. And again, this might seem kind of silly that we're just creating a simple function here that the Boggle board totally could do itself. But again, when I'm thinking about a dice, the dice has a property of being rolled. So that should be in my Boggle dice class. So we do random choice self.values. And then in my Boggle board, I could just do right. So again, to me, that just makes more sense. Having a roll method on the dice, because it's dice, you typically roll dice. So that's why I created that Boggle dice class. So we can call roll, and that should give us a random value. So in this case, I don't think we need import random anymore. Comment out our alphabets, length and stay. Yep, so the randomness is now packaged in my dice. So the Boggle board is not random, it's the dice that are random. So that's, again, it's all packaged in my Boggle dice class. Does that make sense? I wanna make sure I'm not kind of just rambling without making sense.
Yeah, like this is like that idea of encapsulation. Like it seems a little silly now, but if you do this a billion times, that's gonna pay off.
Right, and then so again, kind of think about it, kind of extending the model. So we're not gonna do this, but let's say we're a casino in Vegas and we want to kind of cheat our customers. We could have weighted dice. So, maybe this won't be totally random. Maybe it'll lean more on one. So that functionality, again, our Boggle board should not change in that case. The functionality that's changing is in our dice. So our Boggle board should be left untouched, but the dice might implement something differently. And yeah, as Jack was saying, the abstraction or abstraction there is Boggle board should not care what Boggle dice is doing. All Boggle board should care is it gets a value back from Boggle dice when it rolls it. The rolling can be something else. Like for example, if I always want to return A or the first value, that's up to the dice. Again, let's say this is just a magic dice that always lands on the zero face. Well, then again, Boggle board shouldn't care how it's implemented. All Boggle board cares about is that dice exists and that a dice can be rolled. The rolling logic is packaged up in the dice. Again, this is kind of like, again, seems kind of silly for this case because, again, this dice class isn't doing much. But the idea is that the dice is the component that's controlling the rolling, not the board itself. Again, hopefully people kind of understand that. I know might be kind of strange thinking about it because, again, you can get this to work in multiple ways. I've said that. It's true. For algorithms and design, you could design it in multiple ways. The question is, what's the best design? What's the most sensible design? Kind of factoring everything that you're going to be doing. So, yep, in this case, I create this roll method. I don't let's say I developed the Boggle dice class, and then Jack was developing the Boggle board class. Again, he shouldn't care how this is implemented. All he should care is it gets him the correct output. That's again the separation of code responsibility there. Okay, so I'm done with that roll. I have Boggle dice. I think in my head, I think I checked off everything I needed to, but this is where we
forget to return the roll.
Very, very, very good. Thanks, Sarah. You got my back here. Yep, I was totally gonna just not return anything here. So I've seen this mistake students make. Apparently, I make it also. Your function might be doing a whole bunch of stuff, but always remember you need to return something. So printing out something is not returning it. Calculating anything is not going to by default return it. If I didn't have this return here, my roll method would return a none value by default. So yep, great catch there. I totally missed that. All right, so returning a random choice. Great, roll. So this is going to break our spec file because this will no longer be true because the randomness is now packaged in here and we don't have a custom seed that we're using there. I don't know. I'm not sure actually if this would save us.
Ankur, quick question for that. Could you pass a reg expression in there instead of if you scroll down to in your spec file for the test case. So could you pass a reg expression here just to make sure it doesn't, would that be a good test case versus just testing that it's a letter versus a number or whatever,
Yep, no, I agree. That's a good test case. Test board has only letters. Yep. So again, this is something, yeah, it makes sense. Again, my test cases that I wrote are not extensive, but you're totally right. Again, if I'm developing this, I'm going to hand this off to Kyle or to anyone else. like I should have those test cases, make sure like hypothetically, let's say I code this and hand it off to Kyle, and Kyle accidentally adds in some numbers. Well, the test case will highlight or alert him like, hey, you should only have letters, right? So yeah, we could have regex in here. Yeah, again, that'd be a sensible test case. You guys, I think you guys have a good idea of good test cases to add in. I'm not gonna, again, go through too many test cases here, but yep, that would be an excellent test case to add in there. Okay, so Boggle Dice, let's give this a run. Again, my spec file is not gonna be kosher anymore, but I'm gonna kind of ignore that point. All right, so we have our Boggle challenge, Python runner to run it. Okay, so it looks like our dice seem to be working. Do we have a dice with X on it? Yep. All right, so there's a problem here, or not a problem, but a poor implementation issue here. I don't know if anyone can kind of think of what we would still want to add for our.
Right now, our dies are all in fixed positions.
Yep, you got it. Don spotted it. So we have our dice list. The first dice is AAEEGN. So this value over here is always going to be one of those. In the actual game, dice can move around positions. Like the dice in this first slot is not always going to stay there. When you pick up all the dice, you roll them off to the side, I believe, and then you throw them back into the Boggle board. I actually have not played Boggle in a long time, so let's do a quick YouTube video if you guys don't mind. YouTube Boggle promo. Sure, they have a Hasbro's Boggle commercial. We should maybe get a sponsorship from Hasbro.
Colin the Chihuahua is a dearly loved pet. Unfortunately, his owners have discovered Boggle, the only 3-minute word game where players search for words like tree or curve and score by finding words others don't.
Sorry, it's really pixelated, so I'm sure it's poor quality. But
only 3 minutes.
Okay, yeah. So it looks like you have a case and you roll it, so the dice can move around. Is the main thing.
The 3-minute word game that keeps on.
All right, sorry, I just want to watch that commercial. All right, so again, you take the board, you flip it upside down. There's a case that holds all the dice. So yeah, the dice can move around. So that is something we should, reflect with our game. So to do that, I think our Boggle board can do that because our Boggle board owns the dice list. So we want to shuffle that. So if we do, I believe there's a random not shuffle. I have this page open. Yep, shuffle sequence in place. So it looks like I do want my random module here. So I got rid of it before, import random. And then, again, this is reading documentation. So I've used the shuffle method before, but if you're unfamiliar with it, you read the syntax of it. Random, what is the random parameter? Okay, I'm not sure what the extra parameter is for, but my goal here is to shuffle dice every time I shake. So shake is going to randomize the dice ordering. So randomize dice ordering. So I'll do random.shuffle and pass in self.dice list. So I believe, again, this does it in place, so it's not going to return a new list if I read this correctly.
It says it's an immutable sequence. Does that suggest to us that every time we shuffle, it's going to do the same, we're going to have the same result?
So this is saying hypothetically, if you had an immutable sequence, so for example, if you had a tuple, to shuffle it and an immutable sequence return you want to call sample. So this is, again, yeah, if you're dealing with, tuples or anything that's immutable, but in this case, our dice list should be mutable because we have dice objects in a list. So I think this should achieve it. We can verify that by running our code. If you want to actually, let's not print it out. Okay, let's run this one more time. Okay, so to verify, let's look at our first dice. So our first dice has an O in it. And if we went back to our list here, none of these values are an O. So that tells me that we are shuffling them successfully, right? Because there's no O in the first dice here, but one of these dice should be this dice value. So I think only one of these have an X in it. So there's here, we have an X down here. Yep, so it looks like that we're shuffling successfully. If we try to, yeah, so notice that we have an X over here. which is in the 8th slot. So that tells me that this X dice is being shuffled around each time. Because again, there's only one of these dice that have X in it, if I scan that correctly. All right, yep.
When you were scanning through the directions, I saw the immutable sequence, but it was in a different context than what I thought when you went back and looked at it.
Gotcha. Yep. Yeah, I kind of I didn't quite read it because I've used a shuffle method before. But yep. All right. So good use of random here. Always, again, we tell you this often. Half your job is going to be reading documentation, especially when you're new to using new functions. But okay, so we randomize the dice. We seem to be printing them out. I think we achieved our objective here. We're using actual dice instead of just random letters from the alphabet. So, we could probably add some test cases, but in the interest of time, I'm just going to assume that we're pretty good with our implementation, commit our second part, and we have one more part to do. So git commits completed part 2. What was part 2? Smart Boggle board. Okay, and set the save point. Last thing we need to do, I'm going to try to do this quickly, is there's a QU dice. So Q value always should have a U paired with it. So we need to handle that in some smart way. So let's add some spacing here also so that everything looks correct. So first thing I'm going to change is my board printing, which is over, where is it? So
Ankur, can you get back to your runner file really quick? Because I'm following along so I can and just scroll down, trying to see what okay, never mind. I see what I did wrong. Got it.
Okay, so we're calling shake a few times, initializing a Boggle board. Each Boggle board can have its own dice list. So that's, again, a design decision I made. The reason I made that decision was because I did have the option to pass in a custom length. So in that case, if I change my length to 5, I need to pass in 25 dice instead of just 16. But okay, so we need to handle this QU case, and that's going to be a little annoying. We want to space out our values for printing. So I'm going to handle that first because that's a little bit easier to do. So in our print board, each time we print out a character, I want to print out a space after it. So print X, let's put a space here. Let's see if that does what we want. Okay, so we got our spacing here. Maybe add 2 spaces for good measure. Okay, so our board now looks like this. Now we could slide in a U. So QU, how do we handle this? So when we're actually playing the game, so part 2 is actually trying to find words. We need to interpret all the Q as a QU. So I'm not sure if we would just want to print out QU. I think our dice value should actually be QU. So how can we handle this? I think this is where our dice might come into play. So we might want to special case this. So let's say value equals our random selection. If value equal Q, then value equals QU. All right, so this is something our dice is going to take care of so that our Boggle board shouldn't have to worry about any special casing. So we do that. Any Q that we see on our face will be returned as QU, so that will achieve some of it. I think the only problem we'll run into is our output here. So let's see. So yeah, if this is a 2-character letter in the case where it's QU, then we don't want to necessarily put in 2. But let's deal with that last. So let's see if this actually fixes it. All right, so notice we're getting QU in here. Okay, so that was a simple change. Again, we have this dice object, and the dice object is taking care of that. So again, the Boggle board shouldn't care the implementation. It's just taking back whatever the roll value is getting. However, I guess the Boggle board does need to care in the output, because if you notice that this H is shifted over because this Q is taking up 2 spaces instead of 1. So maybe we should smartly handle that somewhere here. So that's coming from here. Let's do something. How can we pad a value?
If we wanted to do it without a test, we'd add a space to every other letter.
Space, yeah, that's true. That's one way we could achieve it. So John's suggestion was we could just return the letter plus space. I think the only issue with that is when we're implementing, again, when we're playing the game, as in creating that algorithm to find words, we're going to have to deal with those spaces then. So like if we're trying to spell cat, we're going to be looking for C space A space T space. Yeah, so that would achieve the output, but I think we still want our letters to be fixed here. So we don't want to store, I don't think we want to store C and the space character inside of our dice. But that's a good suggestion to solve, I guess, the output. I'm thinking we could solve it here, because this is where we're actually adding these spaces in. So we could do, I'm sure there's a better way to do it, but we could do something like,
If roll equals QU or roll.value, right?
If the like length of the X is 1, then you add 2 spaces, and if it's 2, you add 1. It's roughly the logic that I ended up.
Add 2 spaces minus the 3 spaces minus the length of the character.
Yep, that's something I'm trying to, that's what I want to do ideally. I'm wondering if there's a way to pad. So it looks like there's left padding. It's for numbers.
Yeah, Sarah dropped a link to a padding strings in Python tutorial. Yeah, you're on it.
He found the same link.
Yeah, Google tends to point everyone to the same thing. Yeah, so I want to pad it to the right.
Padding was up above.
Up here? I want string padding here. So I think this was number padding. Okay, I'm going to quickly try this. If not, I do know a way to solve it without using padding, but I just want to see. So left. Just want to pad left. All right, I'll try L-just. If this doesn't work, then we can do something else. So L-just width should be 3. And do I need to tell it what to pad it with? So let's try. Okay, that seemed to take care of it. Quick Google. So L-justify will add spaces to the right because it's going to justify your character to the left. I guess it's a little backwards than what I would expect. But this is saying I want three characters per printout. And so this, again, this is a little generic. So it's not going to just deal with the QU case. Like let's say hypothetically, Z's are always come with the letter O. I mean, that doesn't make sense. But again, this is flexible enough where any character, any multiple character, face value should be fine. Okay, cool. So we handled the QU case without too much effort. 2 changes we had to make. Again, we special case our dice roll so that the dice takes care of the Q rather than the Boggle board having to worry about it. And for our display purposes, the Boggle board, I guess, needs extra functionality, knowing that you might get returned something that's not just one character. So pad string based on character 1.
So a little comment about some of your design choices. It does turn out there's a British English that has a different letter distribution, so it's a good idea to load that stuff from a file. And there's a Spanish one, which of course has some different characters, and there's also a 5x5 version.
There you go. Yep. So again, I made mine a little flexible. Length should be easy to implement. Different letters. Again, we could pass in, I guess, different dice lists. So that's something that this will allow for. So yeah, hopefully, if anyone else wants to customize it, they can. All right, so I'm going to commit this. This is part 3. Thanks for bearing with me. This was definitely a longer challenge. Where did my Boggle page go? So this is dealing with SPQU. Part 3. All right, so I have my 3 save points. I'm going to push all those to origin. All right, cool. So that was part 1 of the Boggle challenge. Part 2, I am not going to go over, although I would like to at some point. But let's kind of quickly take a peek at it and maybe just come up with ideas on how to tackle it. So where were we? This was yesterday, part 2. Again, something I highly recommend. If you guys have time for it, please attempt it, even if you don't complete it. So part 2, we're asking you to find a way to search for a word. So board should have a method called include word. Let me blow this up a little bit. Font's a little small. There should be an include word method on your Boggle board that you want to add. You should be able to pass it a particular string, and then you should get a true or false back if that word exists. So if we look for pair, If we go to this, where did that board go? There's this board. So I'm just trying to think of a good algorithm for this. So I think the way I solved this was using recursion, which I know we've not gone over recursion yet, so maybe that's not a fair challenge at this point. But the way I would kind of think about implementing a solution is the simple case is if we have one letter we're searching for. That's hopefully it should be easy. If we have one letter we're looking for, all we need to do is search through our board, and if we find a letter, we return true. If we don't find that letter, we return false. So that's, again, simple case, but the actual challenge is multiple characters, right? So if we're looking, again, boiling it down to the simplest case, we're looking for a 2-letter word. So let's say we're looking for the word in, right? How do we go about doing that? So if we're searching for in, I would say probably search for the first letter first. So we need to find an I. If we don't find an I in our board, then we know for sure that in does not exist on our board, right? Because if there's no I, we can't make the word in. So I would have my algorithm kind of go through each letter and look for an I. So start at my start. Is this an I? Nope. Is this an I? Nope, nope, nope. And then we find an I. Once we find an I, we had to search for remaining characters. So I is checked off. Then we need to find the N. So to find the N, I would say, what's our search space next? Our search space would be all corresponding letters. So I'd create like an array that has indices. I'd say, based on this I, my valid next indices would be 0, 1, 2, 4, 6, 8, 9, 10, if I counted this correctly. So I'd create an array of indices saying, hey, these are my next valid indices list. And then I would research my entire board, or at least those indices. So I would say, hey, does index 0 have an N? Nope, nope, yes. So if I get a yes, well then at that point, I've exhausted all my letters, so I can return true. But if this were a 3-letter word, we need to kind of repeat that over and over. So if, let's say we're looking for the word, let's go with int. I know that's not a real word, but in programming, we have int. So if I did that algorithm, I'd go, all right, we found an I. These are my valid next cases or next indices. Once we find that N, we do that same thing again. We go like, hey, these are valid next indices. However, there's one more caveat. In Boggle, you're not allowed to reuse that same letter. So you technically, if we're looking for the word like I and I, if that were a word, you could not do I and I. That is not valid. You can't hop back to the same dice. So in that case, like we need to make sure that we don't re-lap on this I or re-step on it. So if we're looking for a word, we found an I, check corresponding letters. All right, we found an N. Again, we're looking for the word INT in my random example. Now we'd search all corresponding indices, but we need to mark off that, hey, this I is not valid. Okay, so again, it is a bit of a challenge to kind of get that algorithm down onto your screen, but that's kind of how I would approach it. Just kind of break it down into smaller problems. So first goal should be just find the first letter and then figure out, all right, we need to find our next letter and keep doing that until you get through your letter list. But if you ever hit a false point, as in if I'm looking for the word like if I'm looking for if, and I have this I, or maybe a better word would be like ice. I'm looking for the word ice. I find an I, but then I don't find a C around here. Well, I don't care about the E because I never found that C. So once I don't find a letter I'm looking for, I return false. And that should be what my algorithm does. Okay, so again, please give this a try when you get a moment. Again, you guys have a lot on your plate, but I think it's a good extended challenge to kind of test your algorithmic skills. All right, with that, any questions about our Boggle challenge? Hopefully, again, you guys get a chance to attempt it if you've not. But again, the first part is good designing challenge for using classes, and the second part is more algorithmic.
All right, I had misunderstood Boggle as only being straight lines, and that would have been a much more difficult algorithm to me.
You said, so your Boggle board was 3x3?
No, I'm saying I misunderstood that Boggle lets you go in any direction for every step.
Gotcha.
I was under the impression that after the second letter, you had to continue in the same direction.
Gotcha. Yep. Yeah. So in that case, yeah, if you're looking for the word ran, yeah, this would be valid. So yeah, I think Sarah's saying she continued on the same direction, which makes the algorithm a little easier. But yeah, so in Boggle, you can go in any direction. You don't have to continue on the same path. But yeah, Sarah, let's see if you can, update your solution based on what you have. That'd be a good challenge if you're up for it. Okay, with that, I'm going to stop the recording.